Hey, welcome to Gold's Garage. So today we're going to discuss whether we should balance or not balance Will Casey's L81 1981 Corvette build or not, 350 cubic inch Chevrolet engine. And we initially started calling it a budget build. I'm going to touch on that topic as well. But lots of controversy and questions about balancing, whether we should or not. And you know, one of the benefits of YouTube is you put your message out there and you have an audience of thousands of people with deep and strong knowledge and experience who are willing to take their time and make comments and provide input, and please keep it coming. And if you're watching my videos, I'll make a recommendation, read the comments too, because you'll learn lots from that as well. Back to the subject, we're going to talk about balancing, whether we should balance, the pros and cons. There's probably no exact right or wrong answer. I'm going to give you my take on it. And the other controversial issue is quench. I'm going to deal with that as well today. And before I get to that, I'm going to have a tip of the day today. If you're a follower of David Vizard, you're going to enjoy the tip of the day. So hang in there with me for that. It's not a very long video. But I have to cover off a few issues that I left hanging about parts from the past, because I didn't mention a couple and there was some questions. So let's get that out of the way first, and I'll get back to the sort of controversial subjects. Before I do that, a shout out to Brian Hambley and his class at Forsyth Technical College in Charlotte, North Carolina. Brian's a good old buddy of mine. We raced together and worked together 40 years ago. He moved to the USA and he's had a long 40-year career building engines for NASCAR race cars, basically. And now he's teaching at a community college in North Carolina, teaching guys how to build race engines. What else? So, and coincidentally, one of his students, Brian, called me the other day and said, guess what? One of my students came to me and said, I just watched this cool video from a guy named Gold's Garage. So he already knew me. So we talk all the time. So welcome, guys. So a couple things, first of all, before I get into the controversial issues, please like and subscribe and hang in there. I'm going to make this fast. I'm not going to waste your time, but I'm going to cover off points that people have showed interest in. A lot of these discussions today are feedback from your questions and comments. So one of them is the Corvette Oil Pan. So I made a statement last time. We bought a pan. This is the pan we bought, and Mike checked out the part numbers and went on forums. This is the pan that's supposed to be the correct pan. And usually when I do a build like this of an engine that's been around for a long time, I take the old pan and throw it away because I don't want to sandblast pans. That's a very dangerous thing to do. There's lots of little crevices in there, and if that stuff gets into your oil, it's going to destroy your engine in no time. So I set this pan aside, and when we started looking at it, this pan will not work for Will Casey for a bunch of reasons. And so Mike was good enough to take it home, and without sandblasting it, took 4 hours, restored it to original. But you can see right off the bat, looking at it, doesn't take much to see that the Corvette pan is shallower than just put my straight edge on there. That's the GM pan that's supposed to be right. That's the pan that came off this engine. And the sump is much longer. So it's probably because Corvettes sit lower to the ground. So they're trying to make ground clearance. That's my guess. So on the inside of the pan, the other thing that's even more important than that, I cannot put this pan, because the sump of the right Corvette pan is at the front of the pan, and the sump at the one we have is at the back. So I'd have to change the pickup from the oil pump. And then at the same time, even if we got it on the engine, which we probably could, it wouldn't be good for Will because he'd be losing an inch or so of ground clearance. And when you have a Corvette, that's probably important. So questions from guys, what about the oil pan? So I thought I'd cover that off. A few other parts that I didn't get to mention in the last video. Valve lifters, what valve lifters did we use? Probably one of the most important choices you're going to make if you're going to do any kind of a build. And these are GM Delphi lifters with stellite bases. So they got the little ring around the bottom that you can differentiate them. And Mike did a bunch of research on these lifters for me and could not find any evidence of any failures whatsoever. And I think you have to recognize with camshaft failures, people usually blame the camshaft, but it's not the camshaft, it's a lifter that fails. And the reason why is the lifter is under way more stress than the camshaft. It's like a pinion in a gear. The lifter is in contact all the time. The camshaft rotates and distributes its load over its whole circumference. So most failures are for lifters. If you got the right lifters, in fact, I've done a bunch of hardness tests, and I've read other guys have done hardness tests on camshafts, and they're usually pretty good. Like we're talking 50 Rockwell. That's a pretty hard surface. That's a bearing surface. So good to know that. So we have these good lifters, and we're going to stick to those. Mike's going to show you the detailed information on them. So another thing that's really important, and when I say learn from the comments, I learned something from one of the commenters. So the pistons that we were going to use initially, I say they did not come with locks, so I was able to get some spiral locks from Bill, and they probably would have been okay, but these Seal Powers pistons don't come with that kind of lock. So let's get back. I'll tell you more about the pistons first, and we'll come back to that. So the issue of quench. And so I mocked this engine up. So far, all I've done is pre-assembly. There are no camshaft bearings. There are nothing in this engine. And let me point out the value of mocking up. Before you do anything on a permanent basis, whether it's putting a cylinder head or anything on, mock it up and make sure everything's going to fit together. So I've done all the bearing clearances, measured all the bores, main bearings, rod bearings. This engine is exactly right on spec, and Mike's going to put a screenshot of the actual spreadsheet that I make of all the numbers I have so far. I don't have piston numbers because I'm not going to use these pistons, and this is why. When I mocked it up, what I did is I put a piston in number 1 cylinder and number 8 cylinder. So I got a piston in each bank, and one at the front of the crankshaft and one at the back of the crankshaft. Then I took deck heights. When I took deck heights and calculated quench, our head gasket we're using is a Cometic 23 thousandths head gasket. My quench was going to be almost 60 thousandths of an inch. So that was too much, and we needed to do something about that. So what are your choices? One of the choices is to deck the block, okay? And you can get your quench anywhere you want. The problem with that is this is an original and correct engine for Will's Corvette. It's got the VIN numbers on the block that tell you that. You can interpret that code and it'll tell you exactly what engine and what car this engine came in. And if you deck your block, that is gone. The other thing is, if you deck the block, it's for sure not a budget build. And I'm going to come back to that subject before I finish. So Mike did a bunch of research for me, and he was able to find some pistons. They're still Seal Power pistons. So let me just find the numbers. I had the numbers handy here. The original pistons were Seal Power 345 DCP, and the pistons that Mike found were 361 CP. And the ones that we're going to use have a 12,000 higher compression height. So compression height is the distance from the center line of the piston pin to the top of the piston. So now these pistons are not going to be used. The new ones are going to be 12 thousandths of an inch taller. So that's going to take 12 thousandths of an inch of our quench gap out. And now we're going to have a total quench less than 50 thousandths of an inch. Now, if I was going to deck this block, I'd probably take another 5 thou off beside that and get it down to 45 thou. But 49 or 50 thou is fine. It's going to be okay. And that's what we're going to go with. So these pistons are coming out. I got more inventory at Gold's Garage. And the new pistons, I actually don't have them here yet. So when I get them in, I'll recheck the deck height and I'll recheck the quench. And just to confirm what I just told you is correct, and we'll move on. That's an important part. So the other thing about pistons is, when someone watched the previous video, I talked about the fact that they didn't come with the right with the clips, and I was able to find some circlips. Well, the seal power pistons don't come with circlips, which is the conventional way, and they're not much fun putting in anyway. That's what they look like when you spread them out. This one's actually out of a big block, but you get the idea. And you have to fit them in that little groove, and that's what holds the pin from coming out of the piston. So seal power pistons come with their own little, like a little U-clip that's made to fit exactly in that hole. Now, I think I probably would have been okay, but it's always better if you do it right. So the new pistons are coming with those clips, and that's what we're going to use. So I can't remember the name of the subscriber, but thank you for that input, because very, very valuable. So what other parts did I not mention? That's not for that. Oh yeah, cylinder heads. So the cylinder heads and intake manifold. So let's talk about the intake manifold first of all. So the intake manifold, because these Chevrolet heads are basically based on a Vortec head, they're fast burn heads. And so they need to use, the best fit anyway is a Vortec manifold. So here it is. I just got it sitting here for a mock-up. And the nice thing about Vortecs is the way they fit. The bolts go down horizontal or vertical instead of on an angle. They're a lot nicer to put on. And these will match the ports better and work better all around for me. And so one of the other things to show you, these are the heads we're going to use. So just to give you an idea, I use these little dowels and I put them in where the head bolts go. So if you can visualize both heads side by side with these, you just basically drop the intake manifold on. Anybody that's put an intake manifold on before knows it's kind of a tentative little job. You're trying to get all the holes aligned. If you use gasket glue or whatever, Permatex, you don't want to smear that. You don't want to distort your gaskets. And in this case, not a problem. They just go together. So what else do I have to talk about? Okay, let's talk about the balance. So lots of comments about that. Oh, the camshaft. Yeah, thanks, Mike. So the camshaft, we didn't have it last time, but we have it now. So it's a Howard's cam, and the Howard's number, Mike's going to put a screenshot of the cam card. 110951-08, small block Chev. So it's 470 lift and 231 at 50. And it's also, we were just talking about this, 275, 293 advertised duration. So slower ramps than say a comp cam is. That's probably a little easier on your lifters too, to do that. Okay, spark plugs, that OEM recommendation. If you buy these heads on a ZZ6 or a CT400 race engine, or AC Delco MR43 LTS, and the M actually stands for Marine. So the standard plug, if you ever watch pro late model racing all over North America, many of them have these plugs. There are aftermarket plugs that guys use. When I had my pro late model race car, I tried a whole bunch of them, and I came back to these. These actually work the best. And I dyno my engines with these plugs in them. And if you're using these fast burn heads, they are actually a tapered. Even though they're going in aluminum heads, most aluminum heads use a gasket. These are a tapered plug. One other thing, as I mentioned, nothing is in this engine now. We're taking it back apart. Crank's coming back out of it. The pistons are coming off. I'm going to use different pistons, of course, as I already mentioned, and in order to get the quench. When I go to put the cam bearings in, I like to show this cam tool. Now, I've made previous videos about how to install cams. So if you want to find that, go back in the history somewhere back there, installing camshafts using this tool and the other style of tool. Now, the only problem with this one is it only fits small block Chevs. So I also have a universal one that fits any kind of engine. So the difference is you put an adapter on the end of it and you make it fit whatever engine you're using. The nice thing about this, there's no measuring or tightening or adjusting. You slide your bearing over there and basically hammer it home. And it's very, very seldom. Anybody that's put cam bearings in lots has had one or two get dinged up here and there. It happens, but it's a lot less likely to happen with this tool if you're careful, because it's pretty foolproof. So this is an all-star product. It's not expensive. And when I'm doing a small block Chev from now on, that's the only one that I'm going to use. So we're down to the point of the day is balancing. So lots of comments. You're changing pistons and rods. You're going to be way out of balance, and you should rebalance the engine. So first of all, general comment, if Will Casey was going to take this engine to Daytona and drive it around at 8,000 RPM for 4 hours, I definitely would balance it. But he's not going to do that. He's going to put it in his hot rod Corvette and cruise around at 3,000 RPM. Once in a while, he'll probably spin it up to 5,000 or whatever and enjoy it. And for that reason, that's one of the reasons. The other reason is the balance isn't bad. First of all, the most important thing about balancing is the weight of the pistons being balanced and equal. So when I get the new pistons, these are not going to be used. I already mentioned that. When I do get the other pistons that I'm going to replace them with, I'll weigh them, but almost all aftermarket pistons come very, very close, closer than the OEMs did. So that's one of the most important parts. The next issue with balancing is if you're going to have a difference between your bob weight and your crankshaft counterbalance, it should be on the side of the piston being lighter than that. So these pistons, I've actually weighed them on my gram scale. There it is. I weighed them on my gram scale. I weighed the piston and rod. I weighed the old piston and rod. And the difference between the old one and the new one is less than 2%. And so for a street engine, that's going to be just fine. So try to think about it. This is how I think about it anyway. And this is a point of view. There's lots of guys out there say, I've always balanced my engine and it always works. I'm sure they have, and I'm sure it does work. And if that's what works for you, you should probably continue to do that. But is it necessary? Is it essential? Is the engine going to wear out faster? Is it going to blow up sooner? Is it going to rattle more if I balance this engine or not? And the answer is no. It's not going to be any difference whatsoever. The cycles to failure is not going to be any difference. In fact, one of the interesting things is imbalance is more likely to show up when an engine is idling than when it's running at higher RPM, because here's the reason. When the piston is going down, so you're worried about a few grams of imbalance compared to your bob weight or your crankshaft counterbalance and the way your piston and rod. So the piston is going down under pressure on the power stroke, and if you have probably 1,000 psi of compression pressure on the power stroke, that's about 6 tons pushing down on the piston. And that's a lot of imbalance, and there's not much you can do about that. When the piston comes back up to the top and it doesn't want to change directions, it wants to keep following Newton's law and keep on going in a straight line. And at the same time, when your overlap cycle, your exhaust valve is open, it's creating a huge vacuum that's trying to suck the top off that piston. That's creating a large imbalance as well. And so a couple of grams here and there compared to your bob weight is not that consequential. In fact, I would suggest that the only time a crankshaft is really imbalanced is when it's on the crankshaft balancer, when there's no external forces applied to it. Now, having said that, once again, there's nothing wrong with balancing. It's a good precision thing to do. I have balanced some of my engines because there's specific reasons to do that. But on a budget build, like Will Casey's, like this, it's not necessary. This engine is going to last just as long as it did, as it would have balanced or unbalanced. The bearings aren't going to wear out. It's not going to shake, and it's going to be just fine. Trust me. So I've done lots of engines that were balanced, and there's always a reason to do that, and lots that aren't balanced. So that's my take. That's my point of view. And other guys have points of view, and I respect that, and that's what works for you. But once again, there's probably no real exact right or wrong answer on that. So I think we're getting to the end. Just to sum up, the tip of the day. So I mentioned if you're a David Vizard follower, tip of the day. And so I got to clean my hands off here because if you want to have a really strong and deep understanding about building small block Chevrolet engines, buy this book. And this book is by David Vizard. I bought it quite a few years ago. I've read it more than once. I've read some parts of it multiple times. And if you go back in history, I read Bill Jenkins 50 years ago. I read Smokey Yunick 50 years ago. All these guys. And this is the most valuable document I've ever found about building and designing small block Chevrolet engines. So shout out to David, and we'll put a screenshot of that in there as well. And David was nice enough a little while ago to make a positive comment on my channel. I was honored by that, but that's not why I'm telling you this. One of the reasons I'm telling you this, if you buy it, go to page 50. We're going to put a screenshot of it. And pretty much everything that I just told you about balancing is consistent with, it's not exactly the same, but it's consistent with what David Vizard's point of view is on balancing. So check that out and then do whatever makes you feel is the right thing to do. Please like and subscribe. Thank you for watching Gold's Garage.